This video will acquaint you with the SpectroVis Plus spectrometer, and specifically for measuring Beer's law. In lab, make sure you only have the USB plugged in and Logger Pro software on. You may also download spectral analysis on your smartphone or iPad and use it wirelessly. This is the inside of the spectrometer. There's a white LED that shines through the sample, and a small slit directs the light through a lens and focuses it on a diffraction grating that splits the light up into its components across a digital, linear detector. And then the whole rainbow is measured at once, very quickly. In Logger Pro, the first thing you're going to need to do is go to calibrate the instrument. This is important on any instrument. You click on spectrometer 1, and you need to let the instrument warm up for a few seconds. We're just going to skip this for demonstration. The reason you need to do this is so you can get a good background signal. For the video, let's hit skip warm up. You should not do this. And then we can show you how to put your sample. Your blank has everything in it except for what causes color formation. In this case, SCN. We put the sample in with the clear sides going with the light. This example shows a laser hitting the sample. And every time it hits a air, glass, air plastic, or glass water interface, you'll see a reflection. So we need to put the cuvette in with the sample so that we can subtract this from our signal. If you don't put this in, your spectra will look terrible. Notice cuvette has a clear side and a frosted side. Hold it by the frosted side. If you have fingerprints on the clear side, wipe them off with a Kim wipe. Make sure you put the clear side with the light. Now with our blank sample in, we can hit finish calibration and look at your spectra. It should be a nice flat line. So let's hit collect, and you can move the scale up a little bit by moving the cursor to the corner. And notice you have a nice flat line all the way across. And you can just pour it in. And if you look in here, you can see the light goes through right about here. Okay, so you just need to have it full about 3/4 of the way. You put that in. Full of iron thiocyanate. It looks really orange. So first of all, why does it look orange? It absorbs light right about here, about 400 and some nanometers. We'll see exactly where in a second. But it lets through all this yellow light and red light. So it looks orange because that's a mixture of yellow and red, and a little bit of green is orange. Now we want to collect data right here for all our samples, all our standards, and all our unknowns. So we're going to click here, and we're going to say, let's just do absorbance versus concentration. So we'll pick the maximum peak right there. We'll hit OK. And you want to hit yes here. Just it makes it so you can see this. OK, we'll hit yes. Puts that there. Let's go ahead and put in our low standard, and we'll work up. You can pour this out. We have a waste bucket. Just pour that out. You start with a low standard. You can just rinse it out with the next sample, but I had a high standard in there, so we'll rinse that out. Start with a low standard. So I can put a little bit in here. Okay, the low standard is in. It's reading this. As soon as this stabilizes well, we'll hit keep. And the software actually will make a curve for you. We're going to take this data and put it in Excel. But the low sample in my case here is 0.000625. So put that in. And now let's put the next sample in. So by starting at our low standard and working up, we can just pour a little bit in and pour a little out. Okay, you see the absorbance popping up there? And it'll kind of go up and down right there. Let's say keep. And this concentration is 0.002. Let's hit OK. And our scale is way off of whack here, so we can just If you hit this button here, it'll auto-scale it. And it's off screen, sorry about that. Then you put our high standard in. Spins out the cuvette with that. Run that. Last standard in. And you see the absorbance going up. As soon as that stabilizes, let's keep that. And this one is 0.004. Let's hit OK. And I'll move the graph over so you can see that. You're going to take this data and put it into Excel, but you can go ahead and look at the graph right now. You can say linear fit. Actually, I got to hit stop first. Sorry. You hit stop, then linear fit, and it gives you y equals, here's your m value and b. So now you want to go ahead and collect your unknowns, and I think the easiest way to do this, you can just put your unknown in, and it'll give you a number. Let's go ahead and hit collect again, and let's just append to latest here. And I'm going to delete this, because we're going to go ahead and do this in Excel. You can just go ahead and put your unknown in. I'll just leave my last sample in, but you'll put your next equilibrium solution in, hit keep, and let's just go ahead and put 0 here, because we don't know what it is. Hit OK, and your first unknown will be that. Then you'll say, OK, put my next sample in. I'll just put a fake unknown in, and you see the absorbance going up. Now I hit keep, and I'll just say that's 0 again. Now we have our 3 standards. Here's the absorbance. You'll put this in Excel and make a nice graph like this. And then you'll take your unknown and use the graph on Excel to find the unknown concentration.